Welcome to our presentation on carbon capture correlation, advancing climate solution through innovative technologies and collaboration. In today's discussion, we'll delve into a critical role of carbon capture technologies in combating climate change and how the carbon capture correlation is leading the way in advancing these solutions. From exploring various carbon capture methods to highlighting ongoing projects and partnerships, will showcase the correlation efforts in driving meaningful progress towards a sustainable future. First, let's define the carbon capture. Carbon capture technologies play a crucial role in climate change by capturing carbon dioxide emissions from various sources such as power plants, industrial process, and even directly from the air. These technologies prevent CO2 from entering the atmosphere where it contributes to global warming. Uh, there, there are several types of carbon capture technologies. For example, number one, post-combustion capture. This involves capturing CO2 from exhaust gases of power plants and industrial facilities after the fuel has been burned. And second is pre-combustion capture. Here, carbon is captured before the fuel is burned, typically by converting it into a gas and separating out the CO2. Number 3, oxy-fuel combustion. In this method, fuel is burned in pure oxygen instead of air, resulting in a flue gas mainly composed of CO2 and water vapor, making it easier to capture. And the last one is air capture. This technology involves removing CO2 direct from the ambient air using chemical process or materials. The importance of carbon capture. The importance of carbon capture lies in its potential to significantly reduce greenhouse gas emission by capturing CO2 at the source. It helps industries transition to cleaner energy sources while reducing their carbon footprint. Additionally, carbon capture can play a crucial role in achieving climate goals, such as outlined in the Paris Agreement by helping to limit global temperature rise and mitigate the impacts of climate change. Next is brief history and mission. The carbon capture coalition established in 2017, in a coalition comparing business labor unions, environmental organization, and energy companies. It was formed with a mission to advocate for policies supporting carbon capture technologies to address climate change, create job opportunities, and bolster energy security. What are the objectives? Number one is promoting policies. The coalitions aim to advocate for policies that incentivize investment in carbon capture, utilization, and storage CCUS technologies. And second is advocating for regulatory support. It seeks to advocate for regulatory frameworks supportive of CCUS deployment. Number 3, securing funding. One of its objectives is to secure funding for research and development in the field of carbon capture technologies. Number 4, increasing investment. The coalition strives to increase both public and private investment in CCUS. In CCUS. Number 5, infrastructure expansion. It works toward expanding carbon capture infrastructures to facilitate wider adoption for these technologies. Number 6 is stakeholder collaboration. Fostering collaboration among stakeholders and is emphasized to accelerate the deployment of carbon capture technologies. So, Pre-combustion capture involves capturing carbon dioxide, CO2, before it is generated by the combustion process. In this method, fossil fuels are converted into syngas, a mixture of carbon monoxide and hydrogen. Through process like gasification, the CO2 is then separated from the syngas before combustion occurs, allowing for easier capture. So next is post-combustion capture. Post-combustion capture involves capturing CO2 after combustion has taken place in industrial process or power plants. The flue gas, which contains CO2 along with the other pollutants, is treated using various methods such as chemical solvents or adsorbents to separate the CO2 from the gas stream. Number 3 is oxy-fuel combustion capture. Oxy-fuel combustion capture involves burning fossil fuels in an environment enriched with oxygen instead of air. This results in a flue gas composed of CO2 and water vapor, which simplify the capture process. The CO2 can be separated from the water vapor using condensation or other methods. So number 4 is direct air capture or DAC. Direct air capture involves capturing CO2 directly from the ambient air. This method is typically used chemical processes or specialized materials to separate CO2 from the atmosphere. Once captured, the CO2 can be stored underground or utilized in various industrial processes. So next is, what is the expected impact on climate change mitigating efforts? So number 1 is significant reducing in emission. With advancement in carbon capture technologies, anticipate a substantial decrease in CO2 emission from industrial processes, power generation, and other high emission sectors, contributing to global efforts to limit climate change. Number 2 is transition to low carbon economy. The widespread adoption of carbon capture technologies will facilitate the transition to a low carbon economy by enabling the continued use of fossil fuels while mitigating their environmental impact. Number 3 is carbon neutrality and negative emission. Carbon capture innovation will play a crucial role in achieving carbon neutrality and even negative emission, helping to offset remaining emission and actively remove CO2 from atmosphere. And the last is global collaboration and investment. Expect increased international collaboration and investment in carbon capture technologies, driven by the recognition of their essential role in addressing climate change and achieving sustainability goals on global scale.